The overall goal of liquid phase scanning transmission electron microscopy is to observe structures and phenomena of nanomaterials in biological samples, fully embedded in a liquid layer of up to several micrometers in thickness.
This method can help answer key questions in the materials science field, such as the behavior of nanomaterials in liquid and the study of biological samples in the natural liquid environment. The main advantage of this technique is that it provides nanoscale morphological information about specimens in liquid. Generally, individuals new to this method will struggle because the loading of the specimen holder and image acquisition are not as simple as for standard electron microscopy.
To begin the procedure, in a clean laminar flow hood, clean a light microscopy glass slide with a fiber-free tissue and pure ethanol. Place the slide on a clean room tissue in a petri dish with a lid. To manipulate the SIN microchips, using carbon-coated tweezers, grab the microchip firmly but carefully on the long sides, keeping the SIN membrane facing upwards at all times. Using this technique, place 5 microchips without a spacer and 5 microchips with a 200 nanometer spacer on the glass slide. Close the petri dish and bring the microchips to a fume hood. Place the microchips in a beaker of HPLC-grade acetone with the membrane side up. Gently swirl the beaker for 2 minutes to remove the protective coating, being careful not to flip over the microchips. Then, quickly transfer the microchips to a beaker of pure ethanol. Cover the beaker with aluminum foil. Gently swirl the beaker for 2 minutes to finish removing the coating, and bring it and the closed petri dish to the laminar.